Hello and welcome to 5 Minutes of Postgres. My name is Lucas, and today we're going to talk about when good correlation is not enough, the cases where BRIN indexes can be worse than having no index at all. This is a blog post by Haki Benita on his personal blog, where he describes a particular situation where a BRIN index performed really badly. That was surprising because they actually seemingly had good correlation between the physical order and the logical order of the values in the table. Let's skip ahead for a moment and then we'll dive into a few of the highlights of the post. At the end of the post, Haki gives some background on how this happened in production. In their situation, they had a table of payment processes, and that table had a high correlation on their creation date column of 0.97 between logical and physical order. Generally speaking, that's a good fit for a BRIN index, and so they added that BRIN index. Initially, it was actually quite fast, but then over time, queries became slower and slower, and queries ultimately started timing out. They were quite surprised because this should have been a good fit for a BRIN index, so why wasn't it actually performing as expected? As Haki describes in his post, the problem here ultimately has to do with outliers. Let's go back up and take a look at a few of the aspects of BRIN indexes to start with. Generally speaking, BRIN indexes will split your table into multiple blocks of pages. And the idea behind a BRIN index is, let's say for example you have 3 ranges here, a range for the page 1 to 3, a range for the page 4 to 6, and a range for the page 7 to 9. And each of those tracks the minimum and maximum value. In this example, for the value E, you know that only the middle block in this case, which contains the D to F minmax, would be matching the value E. You know for sure that the first and the last are not going to include those values because the minmax values there do not include E. It helps zoom in on a particular part of the table. Now, as Haki notes, what Postgres actually does then, it runs what's called index recheck. It looks at the index first, and then in the second step, goes in and actually looks at the table, but it knows where in the table to look and to confirm which rows are actually matching. A BRIN index is not definitive. A BRIN index is a lossy index, and so you have to remember that a BRIN index will always do a table lookup, but the benefit of a BRIN index is working as expected is that it will be a much smaller portion of a table than if it was doing a sequential scan. BRIN indexes are a good fit when you have a statistical correlation between physical row ordering and logical ordering of column values. And this is something that Postgres self-tracks in the pgstats correlation column. It tracks that so that the Postgres planner can make a decision whether a BRIN index, for example, is a good fit or not. Haki runs a quick benchmark to show how a BRIN index functions. He creates a table with 1 million records. Here, it's perfect correlation on the timestamp column because it's just incrementing the timestamps as you create the table. Right now, we get a sequential scan of 1.3 seconds. If we create a BRIN index, we're down to 8.5 milliseconds for the query. And this, of course, is a big improvement. You can also see here a bitmap index scan on the BRIN index, and then it will do that index recheck, and it will actually remove 59 rows that are not matching in the actual pages. When you're thinking about the performance of a BRIN index, this is a very important metric. What was really interesting here is Haki showed a case where BRIN indexes were not working well. And so what he did is every 70 rows, he inserted an outlier, and he pushed the timestamp value that was on that row 1 year into the future. And what that meant, of course, was that the index was looking very differently. What's surprising is that the correlation measurement that Postgres makes still has very high correlation. This still looks like a good index to Postgres, even though it has these outliers. And so when you now run an explain analyze on this query, you actually see that this is worse than a sequential scan. If you remember, the sequential scan was 1.3 seconds. Now we have 3.2 seconds to run the query with the BRIN index. And the reason that's so much worse is, remember, it is a 1 million row table. Postgres actually ends up looking at all of the table and all of the index. And so this clearly is bad. This is not good. This could happen in reality. If you had outliers like this could happen to you. Now, what Haki did here then is show how the new minmax multi-ops operator class that was added in Postgres 14 actually helps you avoid this. The way that works is when you create the BRIN index, you specify that particular operator class. And what that does is it structures the BRIN index slightly differently, so it's able to find outliers like that much better. And so when you create the index with this option, the index does get twice as large. Instead of 520 kilobytes, it's now 1.3 megabytes. But what you can see here is that the query now actually performs almost as good as before we added the outliers. And underneath the hood, as Haki shows here, the way this works is that Postgres will actually remember particular values as well as a set of ranges, essentially remembering multiple sets of pages that are matching. Haki goes into a lot more details, and I would encourage you to read the article if you want to understand everything. But I think what this shows very clearly is that if you have a table that has outliers and you're in Postgres 14, it makes a lot of sense to switch to that new operator class to avoid this problematic behavior around outliers causing your BRIN index to be really slow. Now, I do want to call out one more thing in relation to BRIN indexes. Now, this is a bit of a preview. On August 10th, we'll see a new set of patch releases for the existing released Postgres versions. And I was looking over that, and one thing I noticed is there was a note here regarding BRIN indexes. If I understand this correctly, what this bug here in the BRIN indexes was causing was if you are looking for null values with BRIN indexes, so if the matching data is a null value, then there's actually a bug here where BRIN index could return a bad result. Again, you will see a lot more of this when you actually look at the release notes once they're out in about a week's time. But if you make heavy use of BRIN indexes, this will be a patch release to watch out for and to re-index your indexes after you've upgraded to new patch releases. Thank you so much for listening. This was 5 Minutes of Postgres. Subscribe to our YouTube channel to hear about next week's episode, and talk to you next week.